Hello, this is John Buck back with another discrete time linear systems video. In today's video we're going to talk about the ways we connect systems. We've started talking about basic ideas of discrete time systems, how we talk about their properties, and a lot of practical systems, a lot of engineering. It's not just about making one system, it's about taking a bunch of systems and connecting them together to get the behavior you want out of the overall connected system. And there are three common ways we connect them to build up larger systems from small ones, and that's what we're going to talk about today. Those are connecting them in series, in parallel, or in feedback. Okay? So again, our topic for this video is, wrong color, sorry about that, is about system connections. And so, as I said in the video intro, there's three types of connections we'll use often. The first one is series, or sometimes also called cascade. And that's the idea that I connect one after the other. So I take, say, system 1, I take the output of system 1, and I feed it directly to be the input for system 2. I guess I need to make this arrow a little longer. All right, so I connect them together like this into one big overall system. Y of n is the output of this. So if I were going to do the sort of equation version, I might say, using the operator notation, I'd say that this is the composition, if you've heard that before, of the S2 with S1. Right, so I take the input x of n, I feed it into S1, I take the output that results from that, which is this branch here, feed it directly into S2. The next one is the parallel connection. And so that's the idea that I take x of n, one input, and I feed it into both systems together at the same time. Right, so I sort of make a branch here. I split this and I feed x of n. The same x of n is the input to each one of these systems. I take the two outputs that I get, so y1 of n and y2 of n, and I feed those two outputs into an adder. I add those outputs together to get my overall output. Then the third example, I didn't give the, whoops, before I go on, I should give like the notation for that. I should say that y of n, if I put this in the transformation or operator notation, it's S1, the system applied to x1 of n, to x of n, and S2 applied to x of n. So if someone who likes equations better than pictures, that's the equation for this. And then the third kind is a feedback system. With the feedback system, I take the output and bring it back around towards the input. So what that looks like is that if I draw it graphically, I have my input x of n here. I'm going to need that adder in a minute, but I first go directly into S1 of n, and that gives me my overall system output, y of n. But I take that output and feed it back, hence the name, feedback, into my second system, S2 of n. When I do that, I take the output from this feedback branch and feed it back to add it to the original input. And now we'll see later you have to do this just right to keep everything stable. But those are the three main ways we can connect two systems at a time. We can put them in series, one after the other. I can put them in parallel, where I feed the same input into both branches and then add the outputs together. Or the last example is this feedback example, where I take the first input, or take the input, and I add it to some result of processing another system that's bringing the output back to towards the input. Maybe with this y of n goes in, we'd say g of n comes out. And then, so what I have going on here would be x of n plus g of n that would be fed into the first system, S1. Those are the three main ways we interconnect systems, to simple systems, to build larger, more complicated ones. Okay, so that's all for this video. I'll see you next time.